Okay, we're up to problem number 64. Talks about this function, and in fact, we have 5 problems in a row. We're going to deal with this. So it's recommended that you generate a sketch of the graph before answering the following questions. Okay, well, we do have our calculator. We could let the calculator try to come up with a picture. Let's see, up top we have x minus 2 times x plus 3. And on the bottom, we have x plus 4 times x plus 3. Okay. And here's the graph in the standard window. There appears to be a vertical asymptote appearing and some sort of end behavior, which is probably not the x-axis. Okay, so let's see if we can do this by hand. First of all, we note that these cancel out, and so that gives us a hole at x is equal to -3. And again, we might be able to see that on, if we trace and we put -3 in for x, you see there is no y value that's calculated. It doesn't show up as a whole. Maybe if we do a zoom decimal, if we can pick that up. -3. So decimal. Maybe make the y value smaller. Go down, do -10 and see if that picks it up. Sure enough, there is a hole. Okay, so we have a hole at -3. And what we're trying to graph is this y is equal to x minus 2 over x plus 4. We have our calculator to help us. We should see that there is a 0 or an x-intercept at 2. That's what makes this numerator 0. And for end behavior, we're looking at the ratio of the leading coefficients here. The power or the degree of both numerator and denominator is 1, and the coefficients is 1 to 1. So this is, in the end, getting close to y is equal to 1. And we have this vertical asymptote at x is equal to -4. That would make the denominator 0. So right here at -4, x is equal to -4, we have a vertical asymptote. And again, the calculator will sort of give us a clue as to what's going on. The graph is going like this. Okay, and then we have to remember to go to -3 and pull that one dot out. So there's a dot here at -3, so something like that. Okay, so that would be a relatively decent sketch for this function. And you should have spent some time messing with that. That was the recommendation. Okay, is the graph continuous? No, obviously not, because we have that vertical asymptote. Vertical asymptote, yes. A hole. So now you might want to be thinking, where's the hole? The hole, in fact, occurs at -3. 2 vertical asymptotes, that's obviously wrong. The answer is, in fact, choice D. Okay, choice D. Vertical asymptote and 1 hole in the picture. Okay, the graph has a horizontal asymptotes at various levels. Now, you might, let's see. Okay, so horizontal asymptote at x is 0. Well, that's not even a horizontal line, so let's cross that off. That's a vertical line, and that's a vertical line. So the question is, do we have a horizontal asymptote at y is 0 or y is equal to 1? And I think this was one of the problems that we had an error on, and you had to write down the equation of the horizontal asymptote. Here's the picture. The horizontal asymptote is y is equal to 1. Okay. Yeah, this is a corrected version of the test. Let's see. 66. As x nears the value of -3, the function values approach something. A number of people said it was impossible to determine, but in fact it's not. If we think of this as a function, in function notation, x minus 2, x plus 3, and x plus 4, x plus 3. We are allowed to cross out the x plus 3 as long as x does not equal negative 3. But we can certainly pick values close to negative 3. And go back to my calculator again. Here we are in the standard window. If we trace and we put in negative 2.999, that's pretty close to negative 3. And we see the y value is very close to negative 5. Or we could trace and put negative 3.0001. Again, very, very close to negative 3. And the y value is, again, very close to negative 5. We just cannot put in negative 3. If we put in negative 3, again, there's no calculated value, right? Because we would end up with the expression 0 over 0, which is indeterminate. The answer here is, in fact, negative 5. Sort of a rough problem, but one that most people, I think, got. The y-intercept. So we can do this two ways. One, we can look at the picture, if we have a picture, and realize, yes, there is a y-intercept. It occurs right here. So the question is, what number is that? And we could, look at the choices and go, okay, we know it's not 0, so that's out. And we know it's not 12, that's out. So it's either got to be B, D, or E. For y-intercepts, you should know that you solve this very easily by set x equal to 0. Remember, the equation of the y-axis is, in fact, x is equal to 0. And where this curve crosses the y-axis is going to be 0 for x, and the y-coordinate is yet to be determined. So just go and set 0 in for x, 0 minus 2 over 0 plus 4, and that's negative 2 over 4, negative 1/2. Okay, that is the answer. And some of you may be saying, well, how about this? Well, remember, we can cross those out as long as x does not equal negative 3. Okay, 68. The solution. Where is this thing bigger than 0? And again, let's sort of look at the picture. Here's our picture. And we're looking for, where is this graph bigger than 0? Okay, so bigger than 0 means everything in the positive world, if you want, everything up above this x-axis. These are where y is bigger than 0. And we see two parts of the graph. We have this part in here, where y is bigger than 0, and this part over here, where y is bigger than 0. But this section in here, we see y is less than 0. So we don't want those. Here, we're actually got y equal to 0. We want all the x's from negative infinity out to negative 4. That takes care of this section in here. And then all the x's from 2, right, not including 2, out to positive infinity. That takes care of those. So the answer to that one was choice D, right? Or sorry, B, negative infinity to negative 4, or positive 2 to positive infinity. Notice these don't work. When x is equal to 2, this whole expression is equal to 0. And here, when x is equal to negative 4, this whole expression is undefined. So we can't talk about those. And the other ones are just wrong. Okay. And let's go ahead and stop this one here. And then we'll pick up the next little video with problem 69.